In lecture 1 of electrolysis, we discussed about the basics of electrolysis and electrolysis of the molten ionic compounds. Electrolysis happens in the electrolytic cell having the rods positive and the negative electrode, cathode and anode, and also electrolytic solution from which the ions travels towards their respective electrodes and react together. This is one example from that previous lecture so that we can connect it with this current lesson. So there is a molten sodium chloride using inert electrodes. In this sodium chloride, sodium ion is a positive ion and chloride is a negative ion. Sodium will be attracted towards the cathode and it will gain electrons from cathode in order to neutralize itself. Like Na+, it will gain one electron from the cathode and will be neutralize itself as a sodium metal. In the same way, there is the chloride ion. Chloride is the reacting at anode. Anode is a positive electrode. So chloride ion will be losing electron in order to convert itself into the chlorine. Now, as we know, it has one excess of electron, so it can lose that electron. -1e means loss of one electron, and it will form chlorine atom. Now, chlorine is a diatomic molecule, so better to write as a Cl2. For Cl2, we need two chloride ions, and they will gain 2 electrons in order to make chlorine. Now moving towards the electrolysis of the aqueous solution. As we discussed in the previous lesson that electrolyte could be of molten or aqueous solution. Molten electrolyte means without water. Aqueous electrolyte means with water. So how this works, electrolysis of the aqueous solution. Let's take an example of the same compound in the aqueous form. If we are having aqueous sodium chloride, so the ions which will be present in the aqueous sodium chloride, there will be 4 ions. Like it is aqueous, so there will be positive ion H+ and OH- ion will be from water, and Na+ and Cl- will be from chloride, sodium chloride. So altogether there are the 4 ions, 2 positive and 2 negative, whereas the reaction at each electrode will be from each positive and the negative ions. Either the sodium ion is going to react or the hydrogen ion will be reacting at negative electrode. Same is the case of chloride ion. Either chloride ion will be reacting or OH ion will be reacting at anode. So to make it things simpler, let's have the concept that at cathode the less reactive ions react together and they neutralize themselves into the atom. Now how we can convert that there is a less reactive ion? We will compare this discussion related with this reactivity series, which you can see it starts from the potassium, sodium, calcium, magnesium, aluminum, and then it goes on. There is also hydrogen present over there, copper, silver, gold, and platinum. You should remember about the least reactive atoms that are below the hydrogen in the reactivity series, like it's copper, silver, and gold. On the other hand, for anode, it's very simple that halide ion will be reacting only if it is concentrated form. Like halide ions are the halogens, group 7 halogens in the ionic form. If it's a chlorine, if it's in ionic form, so we call it as a chloride, it's a halide ion. Bromide, it could be halide ion. Iodide, they are the halide ions. Fluoride, F-. So these are the halide ions. They will be reacting at anode when they are in the concentrated form. Otherwise, hydroxide will react in all conditions. Okay, so these are the very two simple rules. For the cathode, less reactive will react, and for the anode, halide ion will be reacting only if it is concentrated. Otherwise, hydroxide will react in all the conditions. Let's now discuss the example. Electrolysis of concentrated aqueous sodium chloride. So it's an ionic compound in the aqueous form. So the ions that will be H+, OH- and Na+, Cl-. Now in this example, we can clearly see there are the two positive ions. There is H+ ion and Na+ ion. Now the concept is that the less reactive shall react at the negative electrode cathode. So let's now compare their reactivity. Potassium ion is the sodium is second most reactive in the reactivity series, whereas if we talk about hydrogen, it is least reactive. So hydrogen will be reacting in this case. Okay, so we will be choosing hydrogen as a react. So hydrogen will be reacting at cathode. At cathode, H+ ion will react. Positive ions always they gain electron from the negative electrode in order to neutralize themselves into the atom. Hydrogen being the diatomic molecule, so it will be form of H2. So in order to form diatomic molecule, two hydrogen ions will be reacting. Altogether they will gain 2 electrons. Each hydrogen ion has a need of 1 electron, so there are the 2 hydrogen ions involved. Now for the negative ions, which we can see, there is one OH minus ion and one chloride ion. Chloride ion is the halide ion. We will also see what is the concentration. Is it concentrated? So we can clearly see there is mentioned that concentrated aqueous sodium chloride. So it will react now. Concentrated, it is sodium chloride concentrated, so chloride ion will be reacting at anode and it will form the chlorine gas. So its 2 chloride ions will be reacting. They will lose 2 electrons altogether and form Cl2. Okay, group 7 ions are the halide ions, so it has to make Cl2. Now if you are supposed to predict the products in the paper, like sometimes you are asked to predict the products at cathode and anode, predict the products. Now in case of products, you are supposed to write down for the cathode, you will write it down that there is the hydrogen, and for anode you will write it down chlorine. You can also write it down the formulas as well. Now for the fourth one, if you are supposed to identify the observations, what are the observations at the positive and the negative electrodes? So at cathode, there is the hydrogen is formed in the gaseous form, so you could mention the bubbles of hydrogen gas, or effervescence, fizzing sound of the hydrogen gas seen, whereas on the anode you could mention bubbles of chlorine gas. If you can further specify, you can also add the colors, like hydrogen and oxygen, they are the colorless gas, so bubbles of colorless gas seen. And for chlorine, it's the yellow green gas. So we can also add the observation in this way. So you could be asked different type of the questions. Sometimes you are asked to construct the chemical equation, the electrode equation, or we can also call these as a half-ionic equation. Half-ionic equation, sometimes you are supposed to predict the products and sometimes you are supposed to describe the observations. So this is the electrolysis of the aqueous solution using the different aqueous solutions. So for example, let's take an example of a compound that is the sulfuric acid, H₂SO₄. So you are supposed to have the aqueous sulfuric acid, and for this aqueous sulfuric acid, if we will break the ions, so it's in the aqueous form, there will be H plus ion, OH minus ion from the water, then H plus ion from this sulfuric acid, then SO4 sulfate ion, SO4 2 minus from this one. So these are the 4 ions which we are having. Now if we want to compare the reactivity of the hydrogen, it's the same element, so they will be having the same reactivity, so they both will be reacting. Now if we want to compare the reactivity of possibility for negative ion, so there is the one hydroxide ion and there is sulfate ion. So for negative ion, there will be halide ion reacting only if they are in the concentrated form. But if they are not in the concentrated form, so what will happen in that case? Hydroxide will be reacting. So let's now construct the electrode equation for cathode. Positive ion will react at cathode and they will gain electrons from the cathode in order to neutralize themselves. It's hydrogen over there, so I am taking 2H plus because I have to make H2 as a product. H2, hydrogen is a diatomic gas, so 2H plus, it will gain 2 electrons from the cathode and neutralize itself into the H2. For anode is a positive electrode and there will be the hydroxide reacting. So there are the 4 hydroxide reacting and they will lose 4 electrons in order to form oxygen and 2 water molecules. So this is the balanced equation. In order to balance that, we are using 4 over here. Why? Because if we use 3 or 2, the equation is not balanced. You can practice by putting 3 and 2, then you can use 4 over here. So this is the perfect balance equation for this one. So if we talk about the observation products, so we can mention these hydrogen and oxygen as a products, and we can also mention the bubbles formation of the hydrogen gas, and oxygen is also the colorless gas, so you can mention the bubbles of the colorless gas seen at anode and cathode. Alright, so this is all about for the electrolysis of the aqueous solution. In the next lecture we will be discussing about the observation of the different reactive electrodes if we are going to react the electrode using the reactive electrode, so how it will be electrolysis. Alright, thank you.